Welcome student. In today's lecture we will discuss unit number 3, numerical methods. In numerical method there are 3 chapters. First is interpolation, second integration, numerical integration, and third differentiation. First chapter is interpolation. So interpolation is the process of finding the value of y is equal to f of x corresponding to the value of x. For example, if the values of x are x0, x1, x2, x3 and values of y are y0, y1, y2, y3. For x equal to x0, y is equal to y0. For x is equal to x1, y is equal to y1. X equal to x2, corresponding value of y is y equal to y2. X equal to x3, then corresponding value of y is y3. Now here x is called argument and the value of y is called entry. For every value of x there exists a particular value of y. That means if you put value of x is equal to x0, then we get y0. If you put x is equal to x1, then we get y is equal to y1. To calculate or estimate value of y, we use interpolation. In interpolation there are 3 methods. First is Newton's forward interpolation, second Newton's backward interpolation, and third Lagrange interpolation. Actually there are 4th method. 4 methods. 4th method is inverse interpolation. Now in this chapter we will discuss only 3 methods. For Newton's forward interpolation and Newton's backward interpolation, we will use difference table or difference operator. So what are the difference operator? There are 5 difference operator. First is forward difference operator, second is backward difference operator, shift operator, averaging operator, and central difference operator. If y is equal to function of x, if y is equal to f of x, we have a given function and h is any fixed value, h is the length of the interval. Let x equal to x0, x1, x2, x3, xn such that x1 equal to what? x0 plus h. That is difference between x0 and x1 is h. That is the fixed value. x2 equal to x1 plus h. That is difference between x1 and x2 equal to h. That means if you add h in x1 we get x2. Similarly, if you add h in x2 we get x3. That is the h is the length of the interval. So xn is equal to xn minus 1 plus h. Also we can calculate y0. y0 equal to what? f of x0. So put value of x0 in function, we get y0. y1 equal to f of x1, y2 equal to f of x2, and so on, yn equal to f of x1. Now here h is the length of interval and xi are equidistant. That means distance between x1, x2, x3 are same. That is distance between x0 and x1 is same, as well as x1 and x2 is same, x2 and x3 is same. All are equidistant. That for example, x equal to 0, 1, 2, 3, 4. So length of the interval is 1. X equal to 0, 2, 4, 6, 8. Length of the interval is 2. So what is the forward difference operator? So forward difference operator, the notation for forward difference operator is del. Let y is equal to f of x be a function of x. Then del of f of x is equal to f of x plus h minus f of x. That means in f of x add h minus original function f of x, that is the next value minus this value. For example, del of y1 is equal to y2 minus y1, del of y3 equal to y4 minus y1. In this way we can calculate del of y1, del of y2, del of y3 and so on. Also this is called as the first forward difference. Similarly, second forward difference, del square fx. Here del square is del into del. Del square is del into del. So here first calculate del of fx. Calculate del of fx. Del of fx is equal to what? Here del of fx is f of x plus h minus fx. Now f of x plus h minus del of f of x plus h minus del of f of x. If you operate this del on each term, then f of x plus 2h, del of f of x plus h is what? F of x plus 2h. Next value, just add h in f of x plus h, so that is f of x plus 2h minus this value f of x plus h minus del of f of x is equal to f of x plus h minus f of x. So if we simplify this, f of x plus 2h, so minus 2 times f of x plus h plus fx. So which is the second difference operator, forward difference operator of fx. Now del of f of x1. What is f of x1? Which is the y1. So which is y1, and del of y1 is equal to what? y2 minus y1. y2 minus y1, it is already written del of y1 is equal to y2 minus next value minus this value, current value, y2 minus y1. Similarly, del of y2 equal to y3 minus y2. Now del square of y2. Del square of y2 is what? Del into del of y2. Del of y2 is y3 minus y2. Now separate del. So del of y3 is equal to what? y4 minus y3 minus del of y2 is y3 minus y2. And if we simplify this, we get, term, we get y4 minus 3 times y3 plus y2. Now we can write this in all these formulas in table. If I are given set of values, forward difference table is in vertical lines, values of x. Now the values of y. Here the values of x, values of y is y0, y1, y2, y3. Now calculate first difference. First difference is y1 minus y0. First difference is y1 minus y0. Second value minus this y0, that is the del of y0. y2 minus y1. y2 minus y1 is the del of y1, and y3 minus y2 is the del of y2. y1 minus y0, this is ये सेंटर में लिखना है आपको, y2 minus y1, y3 minus y2. This is the first difference operator. Similarly, second difference operator, del square y. Del square y is equal to this value minus this value, del of y1 minus del of y0, del of y2 minus del of y1, del of y2 minus del of y1, which is the second difference operator. Here I have written del square of y0 is what? And del square of y1. Similarly, this value minus this value, we get next difference. That is the third difference of y0. Which is the del square y1 minus del square y0. Now in forward difference table, the useful values are del of y0 then this value del square of y0, then this value del q of y0. These three values we are using. Here I have again written the difference table. So del of y0 equal to y1 minus y0, then del of y1 is y2 minus y1, del of y2 is y3 minus y2, del of y3 is y4 minus y3. Again next value del square of y0. Del square of y0 is equal to what? Del of y1 minus del of y0. Del square of y1 is del of y2 minus del of y1. Del square of y2 is del of y3 minus y2. And again next difference is like this. Now we will see in details. Now construct the forward difference table for the following data. Now here data is given. Data is equal to x 0, 5, 10, 15, 20, 25, and values of y are 6, 10, 13, 17, 23, 31. These values are given. This is the x0, x1, x2, x3, x4, x5, y0, y1, y2, y3, y4, y5. Now first forward difference. The first forward difference is what? 10 minus 6, which is a 4. Then 13 minus 10, which is a 3. 17 minus 13, which is a 4. 23 minus 17, which is a 6. Also 31 minus 23, which is equal to 8. Now next difference, second difference is what? How to calculate second difference? 3 minus 4 is minus 1. Then 4 minus 3 is 1. 6 minus 4 is 2. 8 minus 6 is 2. That is the second difference. Next difference is 1 minus 1 is 2. Minus minus become plus. 2 minus 1 is 1. 2 minus 2 is equal to 0. That is the third difference. Now again 1 minus 2 is minus 1. 0 minus 1 is minus 1. That is the fourth difference. Then minus 1 becomes 0. That is the fifth difference is 0. So in this way we can construct the table. Next value minus its previous value. Now here these values are important for us. These first values are important for us. That is, this 4 is important, minus 1 is important, 2 is important, minus 1 is important, and 0 is important. These values are called as del of y0. This is del of y0, del square of y0, del q of y0, del to 4 of y0, and del to 5 of y0. In forward difference table, we are calculating del of y0, del square of y0, del cube of y0, del to 4 of y0, and del to 5 of y0. So next, the backward difference operator. Backward difference operator is denoted by this del, and it is defined as del of fx is equal to fx minus f of x minus h. That is, the del of fx is what? This value minus its previous value. For example, del of y1. So del of y1 is what? Del of y1 is this value minus its previous value is y0. Del of y2 is equal to what? Del of y2 is y2 minus its previous is y1. Del of y3 is equal to what? Del of y3 is y3 minus y2. In this way we can calculate first backward difference. Now second backward difference of y2. Del square of y2. Del square is del dot del, and del of y2 is equal to what? y2 minus y1. Again separate this del. So del of y2 minus del of y1, and del of y2 is equal to what? y2 minus y1. Del of y1 is y1 minus y0. Simplify this, we get y2 minus 2y1 plus y0, which is the second difference operator, which is the second difference operator of backward difference operator of y2 or f of x plus h. This is a table, backward difference table. In vertical lines, x equal to x0, x1, x2, x3, x4. In horizontal line, y0, y1, y2, y3, y4. So first backward difference is what? y1 minus y0, and y1 minus y0 is delta of y1. Similarly, y2 minus y1 is delta of y2, y3 minus y2 is delta of y3, y4 minus y3 is delta of y4. This is the first backward difference table. Del square of y. Second backward difference is this value minus this value. Then this value minus this value. This value minus this, we get this table. So del square of y2 is equal to del of y2 minus del of y1. Del q of y3 is equal to del of y3 minus del of y2, and del to 4 y4 equal to del of y4 minus del of y3. In this way we can calculate this. So this value is what? This minus this value is what? This minus this, and this value is this minus this value. Next value is value separate. This is the third difference. Similarly, we can calculate fourth difference, and fourth difference is what? Fourth difference is this minus this. We get a fourth difference of y4. Now, in this table, the important values are, for backward difference table, important values are this: del of y4, now del square of y4, del q of y4, and del to 4 of y4. In backward difference table, we are taking the last values. In forward difference table, we are taking the first value. In forward difference table, we are taking del of y0, del square of y0, del cube of y0, del to 4 of y0. In backward difference table, we are collecting the values. Del of y4, last value is y4, therefore del of y4, del square of y4, del q of y4, del to 4 of y4, del to 5 of y4, and so on. We will see this in details. Construct the forward difference table for the following data. Here some data value is given. Values of x are 0, 1, 2, 3, 4, and values of y are 10, 15, 20, 28, 34. So values of x are x0, x1, x2, x3, x4. Here is x0, x1, x2, x3, x4, and the values of y, y0, y1, y2, y3, y4. So 5 values are given. Now make the table, difference table. In vertical line, values of x 0, 1, 2, 3, 4. Length of the interval is equal to 1. Y, values of y 10, 15, 20, 28, 35. Now first difference is what? First difference is 15 minus 10, which is a 5. Then second difference is 20 minus 15 is a 5. 28 minus 20 is 8. 34 minus 28 is equal to 6, which is this is the first difference. So first difference. Now 5 minus 6, 5 minus 5 is 0. 8 minus 5 is 3. 6 minus 8 is equal to minus 2, which is the second difference. Now 3 minus 0 is 3, minus 2 minus 3 is a minus 5. Third difference. Then minus 3 minus 5 minus 3 is a minus 8, and after minus 8 all are 0. Now so in the forward, this is a forward difference table. You have to prepare this, you have to memorize this forward difference table, because this is important in MCQ type exam. 2, 3 are values are given. We have to calculate first forward difference or second forward difference. Now here this value is important, 5, which is the del of y0. Then this is the del square of y0. This is the del q of y0, and this is the del raised to 5 of y0. These values are important for us. In forward difference table, we are taking only these values. Second example, the set of points xi, yy, I varies from 0, 1, 2, 3 are 0, 1, 1, 1, 2, 7, 2, 25. Then find the value of del q of y0. Then what is value of del q of y0? Here we have to calculate del q of y0. So values are given, order pair is given. So values of x are 0, 1, 2, 3, and values of y are second value 1, 1, 7 and 25. Now the one first difference is 1 minus 1. 1 minus 1 is 0. 7 minus 1 is 6. 25 minus 7 is 18. So this is the first difference. This column is first difference. Now second difference, del square y0. 6 minus 0 is 6. 18 minus 6 is 12. So this is the second difference, and 12 minus 6 is what? 6. So what is? So this 0 first difference, this is the del of y0. This is the del square of y0, and this is the del cube of y0. So please memorize this. I am taking only the first values, first diagonal. So in this way we can calculate forward difference table. Or now I am taking backward difference table. Now similarly backward difference operator. So backward difference operator is, notation is del. This is the backward difference operator. Already I have defined this backward difference operator. So examples on backward difference operator. Construct the backward difference table for the following data. Data is given, x values are 0, 1, 2, 3, 4, and y values are y0, 5, 9, 6, 4, 8, y0, y1, y2, y3, y4, y0, y1, y2, y3, y4. The last value is y4, and here it is x4. Now the first difference is what? 9 minus 5 is 4. 6 minus 9 is minus 3. 4 minus 6 is minus 2. 8 minus 4 is 4, which is the first difference. अगेन जैसे फॉरवर्ड डिफरेंस में किया है वैसे ही करना है. -3 -4 which is the -7 -2 -3 -5 become plus, so +3 which is the 1 4 -5 become +2 6 which is the second difference. Also 1 -5 become +7 8 1 -7 but 6 minus 1 is 5 and the last difference is 5 minus 8 is -3. Now in this table, in backward table, we are taking the last values, this value, this value, this and this. So this value is called as last value is y0, y1, y2, y3, y4. This is the del of y4. This value is called as del square of y4. This value is called as del q of y0 and the last value is called as del to 4 of y4. I repeat again, this value is called as del of y4. This value is del square of y4. This value is del q of y4 and this value is del to 4 of y4. In backward difference table, consider on last values 4, 6, 5 and -3. These values are important. Similarly, next example, construct the backward difference table from the following values of x and y. So here values of x are given 10, 20, 30, 40, 50 and values of y are 45, 65, 80, 92, 100. This table is given, values are given. So first difference, del of y. Del of y is what? 65 minus 45 which is 20. 80 minus 65, 15. 92 minus 80, 12. 100 minus 92 which is 8, which is the first difference. Again 15 minus 20 minus 5, 12 minus 15 minus 3, 8 minus 12 minus 4. That is second difference, second backward difference. Third backward difference, -3 minus 5 plus 5 is 2. Then -4 plus 3 is -1. That is third difference. Again -1 minus 2 is -3. Now here the important values are last values is this set, which is that how many values are here? y0, y1, y2, y3, y4. Del of y4. This value is what? Del square of y4. This value is del q of y4 and this value is del to 4 of y4. These values are important. ये जो वैल्यू है आप सेंटर में भी लिख सकते हैं. 65, 45 के सेंटर में आप ये वैल्यू 20 लिख सकते हैं. 65, 80 की वैल्यू में 15 लिख सकते हैं. 92, 18 की वैल्यू 12 लिख सकते हैं. बट इन बैकवर्ड डिफरेंस टेबल ओनली कंसिडर द लास्ट वैल्यूज. In forward difference table, consider only first values, like previous example. बाकी कैलकुलेशन सेम ही करना है. नेक्स्ट वैल्यू माइनस दैट वन. नाउ द नेक्स्ट इज द डिफरेंस ऑपरेटर. थर्ड डिफरेंस ऑपरेटर इज व्हाट? शिफ्ट ऑपरेटर, एंड विच इज डिफाइंड एज डिनोटेड एज कैपिटल ई. And shift operator is e of f of x is equal to what? f of x plus h. e of f of x क्या होगा? इसका इंक्रीमेंट होगा h से. नेक्स्ट वैल्यू f of x is equal to नेक्स्ट वैल्यू f of x plus h. दैट मीन्स e of y1 क्या होगा? e of y1 is equal to y2. e of y2 क्या होगा? e of y2 equal to y2 का नेक्स्ट वैल्यू क्या है? y3. e of y2 equal to y3, e of y4 equal to y4, and in this way x से इंक्रीमेंट होगा इसका. h से सिंपली ना ई स्क्वायर ऑफ एफ ऑफ एक्स, ई स्क्वायर ऑफ एफ ऑफ एक्स क्या होगा, एफ ऑफ एक्स प्लस 2h, इसमें 2 से इंक्रीमेंट होगा। ई स्क्वायर ऑफ y1 क्या होगा, ई स्क्वायर ऑफ y1 इज, ई स्क्वायर ऑफ y1 इज y3, e square of y2 is y4, and in this way we can calculate e raised to n f of x equal to f of x plus nh, and also e raised to minus 1 f of x is, इसमें क्या होगा, x से कम होगा, e raised to minus 1 f of x equal to f of x minus h, that means e raised to minus 1 y1 क्या होगा y0, e raised to minus 1 y2 क्या होगा y1, x से कम होगा। सो इन जनरल h से कम और h से ज़्यादा। Now the central difference operator. So central difference operator is denoted by del. Notation is del, and del of f of x is equal to f of x plus h by 2 minus f of x minus h by 2. Del of yn, no need, just memorize this result. इसमें क्या होगा, del of f of x का f of x में प्लस h by 2 लेंथ का हाफ करके उसमें ऐड होगा एफ ऑफ एक्स प्लस एच बाई 2 माइनस एफ ऑफ एक्स माइनस एच बाय 2. थर्ड डिफरेंस ऑपरेटर इज एवरेजिंग ऑपरेटर which is denoted by mu, and mu of f of x equal to what, 1 by 2 f of x plus h by 2 plus f of x minus h by 2. सेंट्रल डिफरेंस में नेगेटिव साइन है और एवरेजिंग ऑपरेटर में प्लस साइन है और 1 by 2 भी। नाउ रिलेशन बिटवीन द ऑपरेटर्स, रिलेशन बिटवीन द ऑपरेटर्स, तो फर्स्ट रिलेशन विथ फॉरवर्ड डिफरेंस ऑपरेटर विथ शिफ्ट ऑपरेटर, डेल इज इक्वल टू व्हाट, e minus 1. We can also prove this, del of f of x equal to e minus 1. So del of f of x equal to what, f of x plus h minus f of x, f of x plus h minus f of x, and f of x plus h is equal to what, which is a e of f of x, and f of x is equal to what, e of f of x minus f of x. You have to take f of x outside, so e minus 1. Del of f of x is equal to e minus 1 f of x, so f of x get cancelled, so del is equal to e minus 1. Similarly, backward difference is del equal to 1 minus e raised to minus 1. Central difference is e raised to 1 by 2 minus e raised to minus 1 by 2. Similarly, these relations are important. Forward difference into backward difference is equal to del square. E into del equal to e into backward difference equal to forward difference, like this. These are the relation. Now example depending on this operator. Now if f of x equal to x square plus 1, h equal to 2, then what is the e of f of x? E means what? Shift operator. We know that e of f of x is equal to e of f of x equal to what? Next value, f of x plus h, and we have already defined f of h equal to 2, f of x plus 2, and f of x plus 2 equal to what? F of x is defined x square plus 1, therefore f of x plus 2 equal to what? X plus 2 bracket square plus 1. Simplify this bracket, x plus 2 bracket square equal to what? X plus 2 bracket square is what? A plus b bracket square, x square plus 4x plus 4 plus 1, and which is x square plus 4x plus 5. Similarly, if f of x equal to x square, h equal to 1, then what is the first forward difference of f of x? We know that first forward difference is what? F of x plus h minus fx. So f of x plus h equal to 1, so f of x plus 1 minus f of x. F of x plus 1 is equal to what? X plus 1 bracket square, since f of x equal to x square, and f of x equal to x square, simplify the bracket, x plus 1 bracket square equal to what? This, x square plus 2x plus 1 minus x square, and if we simplify this, we get 2x plus 1. X square get cancelled. So only 2x plus 1. Third, if f of x equal to x square, h equal to 1, what is the del of f of x? Del means what? Central difference operator. Just we have defined del of f of x equal to function of x plus h by 2 minus function of x minus h by 2. H equal to 1. So function of x plus 1 by 2 minus function of x minus 1 by 2. And f of x plus 1 by 2 equal to what? X plus 1 by 2 bracket square. Already it is defined f of x equal to x square. So f of x plus 1 by 2 is x plus 1 by 2 bracket square minus x minus 1 by 2 bracket square. And if we simplify this, we get 2x. Just simplify x plus 1 by 2 bracket square, like a plus b bracket square. Now next, f of x equal to x square, h equal to 1. Find averaging operator fx, u of fx. First averaging operator, u of fx. So u of fx is equal to 1 by 2 f of x plus h by 2 minus f of x minus h by 2. This is a just definition. Substitute the value of h, so which is f of x plus 1 by 2 plus f of x minus 1 by 2. And f of x plus 1 by 2 what? F of x equal to x square. So f of x plus 1 by 2 is x plus 1 by 2 bracket square. And f of x minus 1 by 2 is x minus 1 by 2 bracket. If we simplify this like a plus b bracket square, we get answer is x square plus 1 by 4. X square plus 1 by 4. If we simplify this, now f of x equal to x square, h equal to 2. Find second forward difference operator of fx, del square of fx. We know that del is square of fx is equal to what? Del into del of fx. And del of fx is equal to f of x plus h minus f of x. Del of f of x plus h minus del of f of x. Now simplify. This del is equal to del of f of x plus h is equal to what? F of x plus 2h minus f of x plus h. And del of f of x equal to f of x plus h minus fx. If we simplify this, we get f of x plus 2h minus 2 times f of x plus h plus fx. And f of h equal to what? 2. So 2 into 2 is 4. X plus 4. F of x plus 4 is what? It is a x plus 4 bracket square. Since f of x is already defined. Minus f of x plus h. F of x plus 2 is what? X plus 2 bracket square. And f of x is already given x square. If we simplify this bracket term a plus b bracket square, we get the answer is right. Similarly, we can calculate f of x equal to x square, h equal to 1 del square of fx. Just apply the same definition here. Del square is del into del. And first find del of fx with the operator and simplify it. So the answer is 2. Now, just I said there are 3 interpolation methods. The first method is Newton's formula for interpolation. Newton's forward formula for interpolation. Second is Newton's backward formula for interpolation. And the third is Lagrange interpolation formula. So Newton-Gregory formula for forward interpolation. This formula is useful for equally spaced values. That means length of the interval is fixed. For example, x0, x1, x2, x3, x4, x5. So length of the interval is h. So 1, 2, 3, 4, 5. So length of interval is h equal to 1, 2, 4, 6, 8 like this. Length of the interval is fixed, which is equal to 2. So then this formula is useful. Now here, consider the set of n plus 1 equidistance values of the function y is equal to fx, like x0, y0, x1, y1, x2, y2. Some set is given xn, yn, and let Pn of x or f of x be a polynomial in x of degree n, then the Newton's forward formula is this. This is very important formula to construct the polynomial fx. y0 plus u into delta of y0 plus u into u minus 1 2 factorial del square of y0 plus u into u minus 2 upon 3 factorial del q of y0 plus and so on u minus 1 u minus 2 up to u minus n minus 1 upon n factorial del raised to n of y0. Now f of x equal what? If the some set of values are given to you, some data is given, from the data we can calculate the approximate function, or we can find the polynomial f of x. Now here u is equal to what? Here u is equal to x minus x0 upon h. Here u is equal to x minus x0 upon h, where x0 is equal to what? First value, beginning value, x minus x0 upon h, and h is the length of the interval. H is length of interval. Now this formula is useful for interpolating near the beginning of set of tabular values. If you want to calculate values of y is equal to f of x at the beginning of the table, we can use Newton's forward formula. Now I am taking one example on this. Given the set of values x and y, x equal to 4, 6, 8, 10, and values of y are 1, 3, 8 and 16. Using Newton's forward formula, find value of y when x is equal to 5. That means find f of 5. Find f of 5. First find f of x and put x is equal to 5. Now in this method, first we have to write down, first we have to draw the table, difference table. Then find the value of u. Then write the formula, forward formula, and substitute the values. Now here x is equal to 5. X equal to 5. This x equal to 5 value at the beginning of the table. At the beginning of the table. Therefore, we use forward formula. If you want to calculate the values at the end of near the end of table, or if you want to calculate value of y at x is equal to 9, then we will use backwards difference formula. Now first difference table, draw the difference table. So x values x0, x1, x2, x3, y values y0, y1, y2, y3. This is a x0, x1, x2, x3, y0, y1, y2, y3. Now first difference is 3 minus 1 is 2, 8 minus 3 is 5, 16 minus 8 is 8. That is the first difference. This is the first difference. Now 5 minus 2 is 3, 8 minus 5 is 3, 3 minus 3 is 0. Now in the forward difference table, as I said, these values are important. So this 2 is equal to what? Del of y0. This 3 is the del square of y0, and this 0 is what? Del cube of y0. Now let fx is equal to y0 from the Newton's forward formula. y0 u into del of y0, u into u minus 1 upon 2 factorial del square of y0, u minus 1 upon 3 factorial del q of y0. Now what is the u? U is equal to x minus x0 upon h. x0 is what? Beginning value of x is 4, x minus 4 divided by 2, and we want to calculate value at x is equal to 5. So x is equal to 5 here. X equal to 5. So 5 minus 4 divided by 2, which is equal to 1 by 2. So u equal to 1 by 2. Now substitute all values in this polynomial. Value of y0, what is value of y0? It is the 1. What is the del of y0? Del of y0 is this. Del square of y0 is this. Del q of y0 is this value. Substitute all values. U is equal to what? 1 by 2. If you put all values in this polynomial, we get f of x at x is equal to 5. If we simplify this, we get 1.625. Second, find f of 25 from the following data by using forward formula. It is already mentioned by using forward formula. So x values are 10, 20, 30, 40. Y values are 1, 2, 4, 7. That is y0, y1, y2, y3. x0, x1, x2, x3. x0 equal to 10. y0 equal to 1. Now 25. 25 कहाँ पर है? 25 at the beginning of the table, middle में actually, लेकिन at the beginning of the table. So apply Newton's forward formula. So in Newton's formula, first write the difference table. So difference table is what? Forward difference table. X 10, 20, 30, 40. Y values are 1, 2, 4 and 7. 1, 2, 4 and 7. First difference is what? 2 minus 1. Then 4 minus 2 is 2. 7 minus 4 is 3. This is the first difference. Now next difference, 2 minus 1 is 1. 3 minus 2 is 1. That is second difference. Again, next difference is 1 minus 1 is 0. Now if from this difference table, this value is important, this is important, this is the important. What are these values? So these are this is the del of y0, this is the del square of y0, and this is the del q of y0. Now here h equal to what? Length of the interval is what? 10, 20, 30, 40. So length of the interval is h equal to 10, and u is equal to what? X minus x0 upon h. x0 equal to 10, beginning value, divided by 10. And we are calculating f of 25. So here put x equal to 25. So 25 minus 10 divided by 10. So 15 upon 10 is 1.5. So u is equal to 1.5. u is equal to 1.5 आपको पता है. y0 की वैल्यू इज व्हाट? इट इज द 1. del of y0 आपको पता है. del of y0 is this value. del square of y0, del q of y0. Substitute all values here. We get f of 25, and which is this. If we substitute all values, we get f of 20. Now the next is Newton backward formula. So Newton-Gregory formula for backward interpolation. Now this formula is useful to calculate the value of the function near the end of tabular values. आपको ये फार्मूला कब यूज़ करना है? जब वैल्यू आपको पूछिए एट द एंड ऑफ टेबल. जो वैल्यू आपको कैलकुलेट करना है वो एट द एंड ऑफ टेबल होगा, तो आपको न्यूटन्स बैकवर्ड फार्मूला यूज़ करना है. अगर वैल्यू बिगिनिंग में है तो न्यूटन्स फॉरवर्ड फार्मूला यूज़ करना है. तो न्यूटन्स फॉरवर्ड फार्मूला इज yn प्लस u इंटू डेल ऑफ yn प्लस u प्लस 1 अपॉन 2 फैक्टोरियल डेल स्क्वायर ऑफ yn u प्लस 1 upon u plus 2 upon 3 factorial del square of yn plus and so on u plus 1 u plus 2 u plus n minus 1 upon n factorial del square of yn. So here in forward formula we are starting from y0 u into del of y0 del square of y0 and so on. In backward formula, so here this value is starting for yn, last value से start होगा. Then u into del of y1. फॉरवर्ड फार्मूला क्या है? u माइनस 1 है, यहाँ पर क्या है? u माइनस 1 u plus 1 upon 2 factorial del square of yn. Now again u plus 1 u plus 2 upon 3 factorial del square of yn, u plus 1 u plus 2 u plus n minus 1 upon n factorial del square of del to n of yn. Now here u is equal to what? In forward formula u का क्या था हमारा, u इज इक्वल टू एक्स माइनस एक्स जीरो अपॉन एच था, लेकिन बैकवर्ड फार्मूला में क्या होगा, x माइनस एक्स एन अपॉन एच, एक्स माइनस लास्ट वैल्यू अपॉन लेंथ ऑफ द इंटरवल, x माइनस लास्ट वैल्यू अपॉन लेंथ ऑफ द इंटरवल. सो x यहाँ से x कैलकुलेट कर सकते हैं, x इक्वल टू प्रोडक्ट ऑफ u इंटू एच, so x जीरो प्लस u h, h is the length of the interval and x n is final value. So this way we can use backward formula. I am using here, given that x equal to 2468 and y is equal to 23819, find f of 7 by Newton backward formula. 7 कहाँ पर है, 7 नियर द एंड ऑफ टेबल, 6 एंड 8 के बीच में 7 है, 7 नंबर कहाँ पर है, एट द एंड ऑफ टेबल. तो हम कौन सा फार्मूला यूज़ करें, अगर ये मेंशन भी नहीं किया होगा तो वी विल यूज़ न्यूटन बैकवर्ड फार्मूला. अगर वैल्यूज़ बिगिनिंग में है तो हम फॉरवर्ड फार्मूला यूज़ करें, अगर वैल्यूज़ लास्ट में है तो बैकवर्ड फार्मूला यूज़ करेंगे. सो कैलकुलेट एफ ऑफ 7. सो फर्स्ट make the difference table. So x values, x0 x1, x values are x0 x1 x2 x3, y0 y1 y2 y3, last value क्या है, y3. तो first backward difference is what, del of y is 3 minus 2 is 1, 8 minus 3 is 5, 19 minus 8 is 11. This is the first difference. Then 5 minus 1 4, 11 minus 5 is 6, and 6 minus 4 is 2. Now backward difference में कौन सी वैल्यूज इंपॉर्टेंट है, लास्ट वैल्यू. What is the 11? The 11 is last value कौन सा, y0 y1 y2 y3. So 11 is del of y3, 6 is del square of y3 and 2 is del cube of y3. Now using backward Newton backward formula, f of x is equal to what, yn plus u into delta of yn plus u plus 1 upon 2 factorial del square of yn plus u plus 1 u plus 2 upon 3 factorial del cube of yn. n क्या होगा, लास्ट वैल्यू कौन सा है, x0 x1 x2 x3. तो y3 n is equal to 3. So y3 plus u into delta of y3 plus u plus 1 2 factorial del square of y3 plus u plus 1 u plus 2 upon 3 factorial del square of y3. Now here u is equal to, how to calculate u is equal to x minus x3 final value, x minus x3 upon h. So x minus 8 अपॉन 2, x माइनस 8 अपॉन 2, और अब हमें वैल्यू कैलकुलेट करना है एफ ऑफ 7. so x इज इक्वल टू 7, 7 माइनस 8 अपॉन 2, दैट इज 7 minus 8 is minus 1 by 2. So here we have to calculate, here u is equal to minus 1 by 2, and substitute the value of this u, which is minus 1 by 2, as well as del of y3 del square of y3 del cube of y3 in this formula. If we substitute all these values here, we get f of 7. So this is the f of 7 after subtracting the values. y3 is equal to what, 19, y3 equal to 90. This is your y3 equal to 19. These values after subtracting we get the value of f of 7 is 13. This is the exercise given to you. Find the value of y when x is equal to 9. X values are given 4, 6, 8, 10, and y is 1, 3, 8 19. So using Newton's backward formula, find the value of y when x is equal to 9. So 9 वैल्यू कहाँ पर है, नियर द एंड ऑफ टेबल. 8 और 10 के बीच में 9 वैल्यू, तो क्या वो कहाँ पर है, नियर द एंड ऑफ टेबल. सो वी विल यूज बैकवर्ड फार्मूला. ऑल्सो इट इज गिवन द डेल ऑफ वाई एन इज इक्वल टू 8, डेल स्क्वायर ऑफ वाई एन इक्वल टू 3, डेल क्यू ऑफ वाई एन इक्वल टू 0. एन कितना होगा, y0 y1 y2 y3. तो डेल ऑफ y3 इक्वल टू 8, डेल स्क्वायर ऑफ y3 इक्वल टू 3 एंड डेल क्यू ऑफ y3 इक्वल टू 0. और आंसर दिया है 13.125. दिस इज द एक्सरसाइज फॉर यू. Now similarly, one of the important example is find dy by dx at x equal to 0 for the tabulated data. Find value of dy by dx, that is derivative of f of x with respect to x at x equal to 0. So x equal to 0, so data values given 0 1 2 3 4, y values are 1 1 15 40. So given that del of y0 दिया है, del square of y0 0 दिया है, और del cube of y0 is 13 दिया है, del cube of y0 is -3 दिया है. So by Newton's forward formula, by the Newton's forward formula, why I am using this del operator is given, forward operator. So y0 plus u into delta of y0 plus u minus 1 upon 2 factorial del square of y0, u minus 1 u minus 2 upon 3 factorial del cube of y0. What is u? U equal to x minus x0 upon h. H equal to 1, length of the interval 0 1 2 3 4. x0 equal to beginning value is 0, so u equal to x. Substitute the value of u as well of values of del of y0, del square of y0, del cube of y0 here. Simplify this polynomial. Simplify. 14 upon 2 is 7, then minus 3 upon 3 factorial 6, which is at minus 2. And after simplifying, we get the polynomial x, which is this 1 plus 7x square minus 7x plus x upon 3 plus 3x square upon 2 minus x, which is your f of x. Differentiate this f of x and put x equal to 0. We will get the derivative of dy y with respect to x. This is f of x. Differentiate this. F of x means what? Which is your y, and put x is equal to 0. Now simply find dy by dx at x equal to 3 from the following table. And this is exercise to you. This given thing is given. X equal to 3 what? X equal to 3 कहाँ पर है? Near the end of table 2 और 5 के बीच में. तो we will use backward difference formula, Newton's backward difference formula. और यहाँ पर डेल डिफरेंस टेबल तैयार करने की ज़रूरत नहीं है. डेल ऑफ y3 दिया है, डेल स्क्वायर ऑफ y3 दिया है, डेल क्यूब ऑफ y3 दिया है. तो डायरेक्टली राइट द पॉलिनोमियल f ऑफ x इज इक्वल टू स्टार्टिंग yn क्या होगा, y3 0 x0 x1 x2 x3 y3 प्लस u ऑफ डेल ऑफ y3 प्लस u प्लस 1 अपॉन 2 फैक्टोरियल डेल स्क्वायर ऑफ y3 प्लस u प्लस 1 u प्लस 2 अपॉन 3 फैक्टोरियल डेल स्क्वायर ऑफ y3. Substitute this value, we get the answer. Now the next interpolation formula is Lagrange interpolation formula. This formula is useful for unequally paced point. Newton forward formula, Newton backward formula are useful for equally paced value, and this Lagrange interpolation formula applicable for unequally paced values. जैसे unequally paced means 1 3 4 6 7 like this. Length of interval same नहीं होगा. So formula is f of x is equal to L of f of x0 plus L1 of f of x1 plus L2 of f of x2 plus ln of f of xn. What is this L? In general, Li is equal to x minus x0, x minus x1 dash x minus xn whole divided by xi minus x0, xi minus x1, xi minus x2, xi minus xn. I ranges from 0, 1, 2, 3, 4, 5 for 3 values. That is f of x equal to what? X minus x1, x minus x2, x minus x3, x minus xn divided by. So here is f of x0. So this value is x0 minus x1, x0 minus x2, x0 minus x3, x0 minus xn. Now second, x minus x0, x minus x2, x minus x3, x minus xn. So x1 minus x0, x1 minus x2, x1 minus xn, f into f of x1 plus and so on, x minus x0, x minus x1, x minus x2, x minus xn divided by x2 minus x0, x2 minus x1, x2 minus x3, x2 minus xn into f of x2. इस पर ध्यान रखिए, f of x0, f of x1, f of x2. f of x0 है तो डिनोमिनेटर x0 minus x1, x0 minus x2, x0 minus x3 एंड सो ऑन. और न्यूमरेटर में क्या होगा, x minus x1, x minus x2, x minus x3. सिमिलरली यहाँ पर f of x है, तो डिनोमिनेटर कहाँ से स्टार्ट होगा, x1 minus x0, x1 minus x2, x1 minus x3 एंड सो ऑन. Now find the Lagrange polynomial through the points. Lagrange interpolating polynomial through the points. Values are given x equal to 0, 1, 2. Values of y are 4, 0, 6. Also find dy by dx at x equal to 2. Also find dy by dx at x equal to a बोला है. पहले तो आपको पॉलिनोमियल f of x फाइंड आउट करना है, उसके बाद उसका डिफरेंशिएशन लेना है, वो x इक्वल टू पुट करना है. कभी कभी इंटीग्रेशन भी बोलते हैं, फाइंड इंटीग्रेशन ऑफ y at x is equal to 2. Now the values are given x0, x1, x2. Values are given x0, x1, x2, y0, y1, y2. तो पॉइंट आएगा f of x0, f of x1, f of x2. तो f of x is equal to x minus x1, x minus x2 whole divided by x0 minus x1, x0 minus x2, f of x0. Second is x minus x0, x minus x2 divided by x1 minus x0, x1 minus x2 into f of x1. And third, x minus x0, x minus x1 divided by x2 minus x0, x2 minus x1 into f of x2. डिनोमिनेटर में क्या लिखना है आपको, यहाँ पर f of x0 से स्टार्ट होगा, f of x0 है तो डिनोमिनेटर x0 से स्टार्ट, x0 minus x1, x0 minus x2. देयर आर टू वैल्यू दोनों, x0, x1, x2. और न्यूमरेटर में x0 नहीं आना चाहिए, तो x minus x1, x डू नॉट राइट x minus x0, x minus x1, x minus x2 प्लस इन सेकंड टर्म यहाँ पर कितना है f of x1, तो सो डिनोमिनेटर x1 से x1 minus x0, x1 minus x2. और न्यूमरेटर क्या होगा, x minus x0, x minus x2. डू नॉट राइट x minus x1, नहीं तो 3 टर्म आ जाएंगे. और सिमिलरली थर्ड टर्म यहाँ पर f of x2 है, तो x2 minus x0, x2 minus x1 एंड न्यूमरेटर में x minus x0, x minus x2. नाउ सब्स्टिट्यूट ऑल वैल्यूज हियर. यहाँ पे क्या x0, x1, x2, y0, y1, y2. y0, y1, y2 means what? It is a f of x0, f of x1, f of x2. f of x0 कितना है 4, f of x1 क्या है 0 and f of x2 क्या है 6. सब्स्टिट्यूट वैल्यूज. सो फॉर फर्स्ट टर्म x1 minus x2 की वैल्यू पुट किया, x1 minus x2 इज 1 and 2, x minus 1, x minus 2, x2 minus x0. x2 कितना है यहाँ पर 2 minus x0, x0 कितना है 0, 2 minus 0 is 2, then 2 minus 1 is 1 into 4. Similarly, substitute all values, we get the polynomial f of x. If we simplify this, we get the polynomial 5x square minus 9x plus 4. This is a function fx. This is a function fx. Now that is your y. Suppose y is equal to 5x square minus 9x plus 4. And if we differentiate this fx, we get 5x square का डेरिवेटिव क्या होगा 10x minus 9x का डेरिवेटिव 9. तो 10x minus 9. So dy by dx is what 10x minus 9. यहाँ पर dy by dx बोला है, आपको इंटीग्रेशन भी बोल सकते हैं. फाइंड इंटीग्रेशन ऑफ fx. So dy by dx at x is equal to 2. So put x is equal to 2, we get 10 into 2 minus 9, which is 11. Second example, find fx by using Lagrange interpolation formula. Also find f of x at x is equal to 1. So values are given x 0, 1, 0, 2, 3. Values are unequally placed. यहाँ पर क्या है 0, 2, 3. 0, 1, 2, 3 आना चाहिए. यहाँ पर 0, 2 और 3. 0 और 2 के बीच में डिफरेंस कितना है 2 का, और 2 और 3 में डिफरेंस कितना है 1 का. तो we can use Lagrange polynomials. So formula is x0, x1, x2, y0, y1, y2 values. तो कितने टर्म आने चाहिए f of x0, f of x1, f of x2. So construct the formula. First x minus x1, x minus x2 divided by x0 minus x1, x0 minus x2, f of x0, x minus x0, x minus x2 divided by x1 minus x0, x1 minus x2, f of x1 plus x minus x0, x minus x1 divided by x2 minus x0, x2 minus x1, f of x2. Substitute the values. f of x0 कितना है 1, f of x1 कितना है 3, f of x2 कितना है 2, और x0, x1, x2, x3 की वैल्यूज आपको पता है. तो substitute all values here, we get function f of x. If we simplify this, we get function f of x, which is this function, and put x is equal to 1. So if you put directly x is equal to 1, no need to simplify, put directly x equal to 1, we get value 2.222. So thank you very much.